So thank you very much. This is a pleasure to be here. I've been keeping track of the Austin Forum for so long. I'll confess that I have attended just a handful of them in the past, but I'm excited that I'm good to be here. So let's kick it off here. Kind of who we are. About me. So my name is Juan Cicada. I've been in Austin since 2006. I came here. I transferred in to do my undergrad in computer science at the University of Texas at Austin. And Austin became home. I decided to go stay here and continue my research. And I did my PhD here at UT Austin. And my research in kind of the last decade and a half of my life has been on this topic called the semantic web and on data integration and putting data together. So we did a lot of work there. My advisor is Professor Dan Maranker in the computer science department. And we just decided we were really excited about commercializing, and we started a company out of that and met Brian a long time ago. Interesting story. Brian did the tech due diligence for one of our VCs. And that's how I met Brian, and kind of our path has crossed for so long. And I'm excited to now know that Brian's company, Data.world, and ours, we joined forces a year and a half ago. So here I am. Brian, a little bit about you.
Yeah. So thanks Juan. Thanks Jay for inviting us, and we're thrilled to be here. Like Juan said, Juan and I have known each other for a number of years. We first met when I was helping one of the companies that one of the firms that invested in Capcenta do the due diligence, and and we struck up a friendship then. We've been stayed in contact ever since. A lot of the research accolades you see Juan has there have been extremely relevant to what we've been doing at data.world. And we first started partnering with Capcenta and then folded Capcenta into data.world about a year and a half ago, almost 2 years ago at this point. And so we've gotten to work really closely since then. Go ahead and go to the next slide. So I'm just going to give couple real quick slides of context up front about data.world and about kind of setting the stage for the topic. So for folks who don't know, Data.world is a public benefit corporation. If you don't know that much about that structure, a public benefit corporation, still very much a for-profit venture-backed company with all the things that normally entails. A public benefit corp is in almost every way just like a C corp, but the additional twist to that is that in our corporate charter, we make a public benefit statement that becomes part of the kind of corporate decision-making process over and above just maximizing shareholder value. And so for us, that is around building the most meaningful, collaborative, and abundant data resource in the world. It's about advocating publicly for improving the adoption, usability, and proliferation of open data and linked data. And if you don't know that term linked data, you will as you go through this presentation, and to help serve as an accessible historical repository of the world's data. The Data.world platform, and this is the last slide about us, and then we're going to kind of launch into the content, is just, you're going to see the world knowledge graph a lot through this presentation. We're going to talk a lot about what that means and what that really is. Our platform is built on top of a knowledge graph, and it helps our customers build knowledge graphs, and our customers and users, I should say. There's two halves to the platform. There's our open data catalog, which that says hundreds of thousands of data sets and hundreds of thousands of users. That's actually, now we can say for definitively over 1 million users. That's true as of, I don't know, what, about a month and a half or so ago. But that's completely free for public use. Over 1 million users, very active community of academic researchers, journalists, folks interested in open data and collaborating on open data projects of all stripes. And then how do we make money? Because, like, as I said, we are very much a for-profit company, is we sell that same set of tools, that same exact platform to our customers who have the same kinds of problems that we have trying to manage a data catalog of hundreds of thousands of data sets with millions of users. Those same problems exist within organizations of all types. And so we sell access to our platform to organizations to use that to manage their own data. And with that, I'm going to hand it over to Juan.
All right. Well, if I like to start talks as like starting with what I want the takeaway to be. So if there's something that you need to take away, you need to leave for whatever reason, it's the following. It's time to literally transform the way we're managing data. We've been managing data for the same way for the last 30 plus years or more. Yes, things have evolved, have changed a little bit, right? We don't call them a data warehouse anymore. We call them a data lake, but essentially those things are the same. And the joke I heard once was, well, we can take a rocket to space, we can bring it back to Earth, it can land on a platform in the middle of the ocean, but we still can't say that these two spreadsheets are the same or how they match. It's pretty ridiculous that we're still in this. So what I want to go is the message of this talk is that the future of data management is this technology we're presenting called knowledge graph, but isn't something that just is new. It's something that has an evolution of history that we'll be presenting about it. But data management doesn't get transformed just by technology. And I think this is one of the biggest fallacies that we've always had, that we just think it's a problem by technology. We must get the people and processes part right, which we haven't. Otherwise, we're just going to be doing the same old thing that we're seeing. So today's world that we're seeing, and today's enterprise, kind of all the applications, all these systems that we have, they're these really complex data systems, and every single application has its own data model. And every single data model has all these costs associated to it. So every single database system that you see has a lot of extra baggage around it. And there's all this logic, all this business logic around it, and it is lost within the applications. And this data is not reusable at all. And it takes so much time and effort to be able to combine data that comes from different places. And the whole vision is that in the tomorrow's world, we don't want the data to be just buried inside an application. We want the data and our knowledge to be first-class citizens. Why? Because applications will come and go, but your data should not. And I think one of the bold things that we're presenting here is that your data should be presented based on a simple and extensible data model, and a data model that is easy to understand by all types of users within the organization. And all this data starts to get connected among all these different types of sources. So what happens is that people sometimes want to be able to go connect and access the data, but they really do not understand it. And there's this big gap. So what is the problem? Problem is, in every single organization, we're going to ask a very simple question. Imagine this is an e-commerce company. We want to know how many orders were placed last month. Well, if you go ask the e-commerce department, the folks who manage the website, well, you get a number. If you go ask the folks in the shipping department, you get a different number. You go ask the finance department, you get a different number. You ask a very simple question to 3 different people and you get 3 different numbers. Why? Well, because this whole notion of what is an order, what is this concept? So if you ask the e-commerce folks, right, for them, an order is when people go on the website, they click checkout or click place order. For the shipping folks, they mean an order is when the customer actually received the package. For finances, when the credit card was swiped and the money came in. So technically they're all right, but at the same time, they may be wrong depending on the context here. And this is what's important. So what is important to also understand is that we want to be able to go answer questions, and those questions may come from data that resides in different sources. And this whole area is what we call data integration. And data integration, I think I like to say that the databases, kind of the coming of age of databases, were invented. Originally comes the network databases back in the 60s, and you have the relational model gets presented by Edgar Codd in the 70s, and this spawns all the work about Ingress and IBM's System R, and then you get Oracle and all these companies coming out. At that same time, one of our locals here now, Bob Metcalf, he invents Ethernet. And I swear to God, it was probably a split second afterwards that somebody said, hey, I got 2 databases. I'm going to put them on the same network, and I want to go query them together. That was probably 40 years ago, and we're still tackling that same problem. That's the problem of data integration. And we've been really tackling this problem from a theoretical point of view, from a technical point of view, on all these different things we do called schema matching and instance matching and data quality and complete data and so forth. But this is the reality. In real world enterprise databases, you have to deal with these databases that are so complex. They have too many tables and too many attributes. I mean, Oracle will sell systems that have literally, their ERP systems have 30,000 tables, and their namings are impossible to understand. I mean, like you would think that you would have column names that are understandable in English. Well, no, actually SAP, for example, is a German company. So those table names and column names are going to be in German. And there have so much, the data is all represented in such a way that it's so hard to understand how they're related. The people who understand this data, they're probably not available, probably retired. They're not here anymore, or there's only a handful of them with the organization. The documentation doesn't exist. And if it does exist, it's probably outdated. So you have a bunch of these technical issues, and it's just for one database. Now, you want to be able to go do what's called the target model. So you have all these databases coming from different sources, and you want to be able to put them all into one single place and one single representation. But I like to say these people try to go boil the ocean. They try to come up with all these requirements, and they try to go reuse all these really complicated models that are there to go represent an entire domain. And at the end of the day, it's like people spend months or years and millions of dollars trying to bring all this data together. And all they have to go show for is this model on a piece of paper and some stuff, but the data is not actually there. And one of the real problems of why the data is hard to get there is because you got to do this thing, what we call mappings. So you have data that comes from different sources, and you want to push that data into this target, and which is where I'm going to go host all this data into one place. Now, creating those connections can be sometimes pretty simple. For example, if I say, hey, in a source, I have something called F name and something called L name. Hey, that actually means first name. That actually means last name. So F name gets mapped to first name and L name gets mapped to last name. But if I have something called full name, I have to know it's F name. I have to concatenate it with the space and concatenate it with last name. But in reality, sometimes you'll have all these systems that are going to be so complex and have so many different names that are just not easily understandable. Or what I sometimes use to say is like, what if on the target side, you have something that the folks think, you know what, an order has a net sales. What does net sales actually mean? Well, that means I take the gross, I subtract the taxes, I subtract the discounts, but getting that information, kind of that mapping, that's not something that we can go do automatically. And that's actually a bold claim I'm going to make is I don't think we will ever automate these types of what we call mappings for the simple reason that we don't have a lot of that metadata. We have a lot of data, and that's why we can do a lot of things in AI right now, because you have a lot of data. But when it comes to creating these connections between different databases, it's all at the metadata level, the tables and column names, and we don't have a lot of that to go train on. So I think that's why we've been trying to focus on this from a technical perspective, but we really continue to fail and end up being on the other extreme of not figuring out how to go do this efficiently. And we just end up kind of doing a lot of stuff very manually. So we really need to understand how to put in the people and the processes into this. Another aspect that we see a lot is what I call the knowledge hoarding threat. And this goes into the whole society, the cultural aspects within an organization. People, I mean, you have knowledge is power. And if I have a lot of this knowledge and I know how things work, I know where this data comes from, and everybody comes to me, I feel very empowered. I don't want to give my power away. Or people are just, people just are kind of lazy too. They're like, it's too much work. I just come to me and I'll tell you the answer. I know what it is. This is a big cultural issue that we have within organizations. And now you have the young millennial workforce going off to the job. How are they going to know what data is out there they can go use? So I'm kind of making this bleak kind of image about data integration, but obviously this is something that we continue to do every day, right? We have all these business questions and we answer these questions from different places, from different data sources. So how do we do that today? So you say, for example, there's a data analyst, they have a particular question and they need to go get data to go answer that question. So they'll go talk to some data engineer about that. They say, hey, I'm trying to answer this question. I need this data. And the data engineer is going to go off and says, okay, I know where it is, but you know what? I kind of know, I'm not so sure. Let me go talk to that data architect to be just 100% sure about that. But that data architect is somebody who's super busy. They may take a while to go get the answers. Okay, take an hour, take a day, can take a week. But at the end of the day, at the end of some time, that data engineer is able to go find that way to go get that data, write some queries, and then go send the data back to the data analyst. And that can sometimes be a spreadsheet that's being sent by email to someplace. So the data analyst takes that data and they probably go do some munging on their laptop in Excel. They generate the report that they were asked for. But this was a one-time static thing, right? So they need to go do this again. And every time that data engineer will provide a new kind of spreadsheet, or sometimes the analyst will do the same type of cycle, but with other data engineers. And what happens is that they start getting all these different spreadsheets together, right? And then sometimes even in spreadsheets, you can make connections between one spreadsheet and another. I mean, have you ever seen that happen when you open up a spreadsheet, you get a bunch of errors? It's because it was looking for this other spreadsheet that it was supposed to be connected to, and that's why things fail. Or sometimes that data analyst will have even a rogue hidden database on their laptop that nobody knows about, and they plug in data there because they're technically savvy enough to go figure out how to go do some extra munging. They generate that report. I've seen billion-dollar companies, they make incredible important decisions based on this process. And you ask yourself, did that data analyst communicate the right message to that data engineer? Did the data engineer actually understand what that data analyst was trying to do? And did they actually get the correct results? And did they submit the correct results back to the data analyst? Ask yourselves these things if you do these types of if you're in these situations. Now, other things that we see all the time is that you'll have, for example, that data engineer says, you know what, I'm too busy. All I'm just doing kind of just mechanical work. I'm going to let you go create your own query, and you can go run a query and do it yourself. And I think we had early on, we were asking people about horror stories. This is a real world story that happened to me. I got people were running this query, and this query literally was 15 pages long, and it's federating over all these systems. And this is the report that's being sent to the executives every morning about all the daily sales. Do we even know what's going on in this query? And funny story is that when in that particular case, we started looking into that query, and we saw a bunch of hard-coded numbers in there. We realized that they were applying some discounts that were completely discontinued years ago. All the numbers they were looking at for the last 2 years were completely off, and they were still making decisions on that. Now you come into the world of, let's go do a data warehouse, where people say, you know, we're doing all this ad hoc process. We're going to go bring in a consultant, and we're going to go get all the requirements, and we're going to go build an enterprise data warehouse, and we're going to go move our data in there. And this stuff takes 6 months and $1 million to go do. And at the end of the day, the analyst says, oh, sorry, I forgot another requirement. We need this other data source in there too. I can't answer my questions without it. So you have to go back and then kind of figure out what was done, change it thing. Maybe the people who wrote those ETL scripts, which are basically just code to move data from one place to another, the people left the organization. You have to reverse engineer the code that some other people did. In the meantime, what happens? That data analyst is still solving their problems with that ad hoc approaches that I presented previously. Now they're being told, hey, stop doing that ad hoc process, which, by the way, you control, and go query this thing, which, by the way, you have no control about anymore. You're going to ask the same question. Do you think the answers are going to be the same? Probably not. So what are you going to trust? You're going to trust that ad hoc approach that you control. And that's why you always hear why data warehouses fail and why people spend so much time and money on this. They don't fail for technical reasons. They fail for social reasons, because people do not trust it. They don't know where the data comes from. They don't know who to go talk to. And they end up boiling the ocean. Now, this whole data lake approach, honestly, all it does is just flips it kind of on the side, but it's the exact same thing. Now, instead of doing all this work up front to put into a warehouse, you just dump the data into the lake, and then you do the work afterwards. It's the exact same thing. Now, the other approach that you're seeing here a lot is you hear now, we need to make these data analysts self-service, right? They need to be able to go, and they don't need to go talk to those IT data engineers. They need to be able to go do the things on their own. So that's fantastic. So you have a data analyst as a tool, they can go do and they can prepare and organize their tool data on their own. But you have another data analyst who has a very kind of a related question, and they're going to go prep their data on their own too, but they'll probably have some overlap data that somebody else did, and so forth. So do you think that the way that the data is being prepped by every single analyst is the same way? One. Second, how many wheels are being reinvented? How many times are people redoing the same type of cleaning organization work? Another example I remember saw once is that a company was talking about they were using this term called large orders, and nobody defined what was a large order. And somebody thought a large order was when there were 10 things in the order, 10 items. Somebody said when there was 20, somebody said when there was 15. All the numbers were off because nobody decided how to go share that knowledge. So at the end of the day, it's like, so what? Right? We've talked about kind of these consumers of data on one side, these producers of data, but there is this big gap in what I call the data meaning gap. And if we don't bridge the gap, this is where we have this garbage in and garbage out, right? I'll get generate data, but then these are data you're going to go do some analysis. You're going to go run your AI machine learning models on it, but you don't know if you can trust this. So the question is, how do we bridge this data meaning gap? And that's where I'm going to go introduce this whole notion of knowledge graphs. But the answer is longer. It's really about a social technical phenomenon that we need to look into. And it's how do we manage people, processes, and technologies together? So what is this thing I'm presenting here called a knowledge graph? And it has a lot of popularity in the last kind of 7 years. But what I call my informal, inclusive, non-pedantic, but non-scientific definition is that you're doing data integration, where you're bringing in a lot of internal and also external sources, but you're also bringing in the real world concepts and relationships that happen to be represented in the form of a graph. So a graph is you have nodes and you have edges, and the edges connect nodes. So basically your nodes are your dots, and the edges are the lines between them. And these nodes and these relationships represent real world entities and objects in the world. So you'll have an order, you have an order line, you have a customer places an order, and so forth. And what we're doing with these is that we're being able to integrate both knowledge and data at scale. So this is not a technology that I'm saying that it's something that was invented recently or anything. This has a large history that goes and has changed names over a lot of time. And there's a historical work that I've actually done with a collaborator of mine, Professor Claudio Gutierrez from the University of Chile, is that we've been tracking the history of all the different events that have occurred for the last 60 years. Going back to kind of in the 50s. So the term knowledge graph gains popularity when Google presents it around 2012. And there's been all these independent advances on the areas of data management, and on the areas of knowledge and logic. And there's been independent advances and also events that have occurred kind of in the middle. One of them, which is a very important event, which has been very big deal here in Austin, was in the 80s. There was a Japanese 5th generation project. And the Japanese were basically beating the entire world in cars and electronics, and they wanted to beat the entire world in software. And the rest of the world got afraid, and the US started organizing everybody to work together. And that's why MCC here in Austin started. MCC in Austin started in the 80s to combat what the Japanese were trying to go do, their goal was to build AI machines that would software and hardware, which happened to be built on Prolog. Right. That's why we get companies like here in Austin called Psych doing all these things in Lisp and so forth. So all of these have had their big important impact to be able to generate these technologies that are now being manifested as this term called knowledge graphs. In the last 10, 15 years has been the semantic web technology stack. And the web is being kind of the basis of being able to go integrate data at web scale. So why are we seeing these knowledge graphs? One, from a data management perspective, computer science is all about levels of abstraction, right? When people tell me, I could do this in X, I could do this in Y, I'm like, you know what? You can do this in electricity. You could do this in assembly code, whatever. Except like, do you want to go do that? That's why we're all about levels of abstraction. So computer science for me is like, you decide in what level of abstraction you're going to focus your career, or as a compiler, you decide I'm going to work on understanding how to move from one level of abstraction down to another one. That's basically computer science. And we see that as data too, right? So now thinking about data as a graph is just a higher level abstraction. That's what you do when you sit on the whiteboard and you talk to your colleagues to go figure things out. You draw a graph, right? A mind map, that's what you do that. And a graph is just this really natural data model to bring in all these different types of data structures. You can represent tables as graphs. You can represent trees, which is like JSON and XML, you can represent those as a graph. When you do have unstructured data, when you do NLP and do entity extraction, the result of that is a graph. And now the cool thing is that you can do a lot of great and new types of analytics on top of graphs, in additional to doing what we've always been doing, right? You're about trying to find really insights within all this connected data. And the latest kind of techniques on fraud detection and on clustering and so forth is being achieved with graphs. And all the pundits are talking about graphs being the next thing. So just kind of a highlight, like Google started this trend of graphs, this thing called knowledge graphs to power search. They have this thing called things, not strings. So that's why when you search for Austin, you actually get a little side panel, right? What we call the knowledge panel. You say, oh, Austin's a city, right? Here's the weather. Here's the population. Or if you search for a person, you get Tim Berners-Lee. Who is Tim Berners-Lee? He was born where? What is he known for? Heck, I even show up on the knowledge graph right now. If you search for my name, you get some information about me. Or you can search for all types of things. One of my favorite drinks, an old fashioned, you can get that information. You're searching and you're getting the thing that you're looking for. So that's the whole idea that Google started introducing, they popularized it. And now you see Amazon, the entire graph of data of all the products on Amazon is a knowledge graph. And that's how they power Alexa right now. Apple, all of Siri is completely powered by all this knowledge graph technologies to be able to go to search and recommendation. Microsoft has this to go integrate all their different products, and LinkedIn does it to go recommend different systems and consumers and products. They even have this economic knowledge graph. I mean, all the FANGs, right? Facebook, Apple, eBay, all these, Microsoft, Google, they're all using these technologies, and they have been for a while now. And now they're starting to go showcase how they're going to how they're using it. All the tech consultancies companies are saying, wait, all the Amazon, the Googles, all these companies are doing it. I want to go do this too. Are we starting to see all these tech consultancies setting up practices to go do knowledge graphs? But let's talk about the people, the processes, and the technology. People. I highly recommend this book by Professor Gerald Kane called The Technology Fallacy. And this quote, the mistaken belief that just because business challenges are caused by digital technology, that they also need to be solved by digital technology. That is something that we really need to understand. So think about it. Remember in my initial examples, I was talking about the data producers and the data consumers, right? A data consumer has the titles like a data analyst, a data scientist. They're the ones who understand the business and need to go answer those critical business questions. The producers are the ones who really understand the data, right? They're the data engineers, they're the data stewards. They understand how the data is represented, how it's connected. They document all that. But frankly, there's something missing in the middle. One of the big takeaways I want you all to have. We need to think about this role that I'm calling the data product manager. And the data product manager's role is the person or the group or the team that's going to serve as a communication bridge between the consumers and the producers. And they're the ones, frankly, I believe that should be responsible for the data. And I think what we're starting to go see is a resurgence of a lot of the work that happened during the 90s. The work of after the whole AI winter, people were doing these expert systems. They were building rules, and they were building rules because they were interviewing the domain expert, the subject matter experts to create the rules, to create this knowledge. And what we're seeing today is this resurgence of not just understanding what things mean from a knowledge perspective, but also connecting it and talking to where is it from the data. So that's why I argue that a team of the data product team will have what I call these knowledge scientists. that they'll work with both sides of the brains, right? They're the creative folks, right? But they're the analytics folks too. So they're the people who can work with the consumers of data. They can get on the whiteboard. They can do the modeling. They can ask those questions of what do you mean by this stuff and really push people. They can go and talk to the data producers, to the geeks, and go ask the data, go query the data, go look at the data, write SQL queries and so forth. And from a social perspective, they're people person, but they're also geeks with geeks too. So they can be able to go do this balance. Now, I'm calling this thing knowledge scientists, and maybe you're all saying, well, how is this related to the data scientist? Well, we always hear this phrase, right? The data scientists spend 80% of their time cleaning and organizing data, right? Well, and only 20% doing their analysis. And that's true. My position is that 80% that is being spent on quote unquote cleaning is very important, crucial knowledge work. And that's what the knowledge scientists should be doing. And honestly, this whole team, the knowledge scientists, they're the ones who should be responsible for your data. Think about it. You generate data and they're going to make an important decision with it. What happens if it turns out to be the wrong decision? Who is responsible for that? But on the other hand, what happens if it was an amazing decision and they would have only been able to do it because of the data? Who's responsible for that? Who takes a lot of the credit for that too? This is something that we really need to start considering. And a lot of, another position is that we need to treat data with the respect that it deserves. We sometimes call this cleaning as data janitorial work. I'm like, no, this isn't just cleaning up stuff over there. We really need to elevate all this data to the concept, to the knowledge that it actually means. So here's a quick little quiz. If you work in data and you consider yourself a data scientist, are you the person who leads conversations between like the stakeholders within the organization to understand their pain points? Are you the person who's debating what a customer means that you hear it so many times? Are you a person who draws on the whiteboard the sketches of what people are thinking about? Do people come to you asking for data? Do you find yourself in the middle of like a data engineer and a business and another business user? Are you the person who maintains a data catalog within your organization? Do you have to negotiate with people to go get data? Do you clean the data? I mean, if you're saying yes to any of these, guess what? You're a knowledge scientist. I would highly encourage you to take a look at this page, knowledgescientist.org, together with Professor George Fletcher and Paul Groth in the Netherlands. We're working on defining what this role is and actually coming up with what is the curriculum within organizations, within universities. In universities right now, you can frankly get a data scientist degree. You can get a master's in data science in less than a year, and you learn how to go do stuff in Hadoop and big data, and then you learn how to do some stuff in machine learning, and but what about the middle? We're talking about what does this data mean, but we're not talking logic. We're not teaching people knowledge representation. Undergraduates go through 4 years of a computer science degree, and they're lucky if they've had 2 or 3 lectures on what is data modeling. And then we complain that we don't understand our data. Well, because we're not educating people on how to think about how to organize their data, organize their knowledge. Processes. Why do we not treat data like we treat software? When we do software, we know how we establish a team, right? We have software engineers, we have people who do quality and testing. We have a product manager. The product manager gets requirements. They go translate them. We have an agile methodology, right? We'll do Scrum. We'll have a Kanban. We'll go short. We'll have stand-ups. We have comments on our code. We do peer reviewing. We do pull requests. We have continuous integration, continuous development. Why we would never even consider pushing code to a master branch without having it a single comment, without it being peer reviewed, without it going through any test. Why do we do that for data? We do that for data all the time. Why do we find that acceptable? It is unacceptable. And that's something that we need to go change. And that's the main message here, is to look at data get inspired of how we do this in software. Now, I'm not saying that every single thing in software to go do with the data, but there's a lot that we need to go learn. And frankly, just to kind of do quickly, this is part of the work and the research that we've been done in the past on how do you create a methodology to go create these graphs that connects data from all together. And an interesting thing here is identifying what does success look like. Success, this is the key, is how do I know that I'm being successful? From a business perspective, success is not getting my data dumped into one place. Success means that my end users are able to go answer their business questions. And that's truly how we've defined a particular methodology that we've done is do your business questions, you start going through these different phases. And I know I'm successful if the people who started with that business question has the data, they're able to answer their question, they're satisfied. And you continue doing this in an iterative kind of pay-as-you-go model. Let's talk a little bit about technology. And with that, I'm going to pass it on to Brian.
Great. Thanks, Juan. So taking where Juan left off there, thinking about that pay-as-you-go methodology, what does that actually look like within an organization? And so starting to kind of stack up some of the things that Juan talked through. We're going to first talk about metadata. Metadata is data about your data. This is both logical metadata, data that that talks about the glossary of terms, the concepts that your data is about in human language terms, but it's also physical metadata. What databases exist? What are the columns and data and pieces of data within that? Fields within files, columns within your databases. The first step is really getting a picture of that roadmap. If you don't have a picture of what you actually have, you can't start to do any of the sort of higher order things that Juan has talked through. And this is actually the state of most organizations. They do not have a clear picture of that metadata. Once you have that metadata, once you have the data, the next question is, how can I access the data? How can I get into that data? And this is where the concept of query comes into play, right? These data resources are large data sources. They contain and accessing them isn't as simple as scrolling visually through the data on your screen. You need to be able to query them, to cut down and subset that data and ask questions of that data to get back the pieces of data that are relevant to your question. But going forward and kind of going back to the theme of knowledge graphs, what do we mean by knowledge graphs? What we mean is there is a higher order beyond that, right? You can have this physical metadata and understand at a very coarse level what tables exist and what they nominally mean, and you can get access to data to query it with SQL and other kind of structured data query languages. But when you talk about layering knowledge into the data, knowledge is, I know that the rows in this table mean information about orders, and I know that some of the data about those orders is net sales per one of the previous examples. Humans know that. We have knowledge in our mind that we can get from reading glossaries and terms and understanding how the business hangs together and how it relates to the physical data assets. But what we're talking about with knowledge graphs is taking that knowledge, that actual understanding of what are the real world entities and relationships, and representing that in a way that the machines can actually use it and help you use it to access data. So we talk a lot about this crawl, walk, run evolution, right? You cannot jump straight to running. You have to kind of hit pause and say the first knowledge graph you're going to build in your organization is actually this notion of a data catalog. It's an understanding of what physical data do I have, how does it relate. With that, you can use that to get access to the data, to query it, to do the federated query that Juan referred to previously. And on top of that, you can start to layer this machine readable knowledge that can drive both human consumption and consumption by machines in AI. So there's a lot, there are a lot of open data portals out there. This is a picture of Austin's. Generally speaking, the open data portals in the world are metadata only. They are basically there to say, here is a description. They're that first layer. They are telling you what data exists through this portal, what can I get access to, and some content meant for human consumption around what does that actually mean. What we're saying is that, when what we call an enterprise data catalog, which is a system that can actually provide deep access to your data in the language of the business for an entire organization, it starts at the bottom with that metadata, that business glossary, that physical metadata, the data governance, who can have access to this data and for what purposes. Layering on top of that, the notion of federation and virtualization. Federation meaning querying between multiple data sources that are physically separated across a network. Virtualization, meaning I want to look at all of this data as though it's just what it really is, which is facts about the real world, and not worry about this is in a SQL Server database, and this is in an Oracle, and this is in my data lake. And then knowledge comes in at the top level with mappings and the concept of ontologies, basically formally representing the logical meaning of what's behind the data in a language that both computers and people can understand. So that first layer, looking at that bottom layer of metadata, that bottom layer of metadata is the knowledge graph. That it has all the same characteristics of any knowledge graph. So in that knowledge graph, you're looking at the notion of, if you kind of start from the bottom and read up, we know that Sally produced this sales report, which was derived from this net sales table, which was derived from an orders table. That orders table is related to the concept of orders, and it's part of the sales database, of which Ruben is the steward. Encapsulated in this relatively small picture, we have a whole lot of information around what physical data I have, what it means related to the real world, who is interacting with this data, and potentially how this data can be used. So in this knowledge graph that kind of sits at that bottom layer, that metadata roadmap that kind of unlocks the door to everything else we do, the nodes in this graph represent your data assets. They represent agents, the people and departments that actually take action with data. They represent topical information like business concepts and glossary, and they represent data and analytical artifacts like your dashboards and reports. The edges represent the relationships between those things, that something is part of something else, related to, derived from, the steward of. Our system in particular, we have an ontology that we've built, which is kind of a key part of our system. It's built on top of a number of open standards, and those standards may not be extremely well known to many folks here, but DCAT is the data catalog ontology. This is basically an open public standard model for representing the notion of a basic data catalog of assets. Dublin Core is actually one of the oldest pieces, bits of the semantic web. It's basically standard, simple, structured metadata about any digital asset. Simple concepts like the title of an asset, the description of an asset, basic things that you would want to be able to say about any digital asset. These things have all been defined, and what we've done is basically stitch them together and add some extra definitions that are really useful in kind of a modern enterprise setting. Go ahead. Data lineage is a really important concept here, and this is very much a part of what that knowledge graph is for, what you would do with that knowledge graph, and what kinds of things are represented. Lineage means understanding the notion that one asset is derived from another or came from another. You would use this for what's called impact analysis. So in this example, you see that I have a network of tables that have been combined through various data transformation processes to result in this retail order table that's my focus in the center, and that there's multiple reports based on this. Here, if I was to say, this turns out this vendor contact information contains personally identifiable information, and I need to watch how I'm sharing it, and I was to mark that red, I'd like to be able to know what reports downstream would now have their access limited based on this. Knowing this kind of chain of custody, of control, of data flow is a really important piece of this model. I'll pass back to you, Juan.
Yeah. So continuing on this, like when you're starting to go catalog and understand what data you have within an organization, like this is the real world view of it. And this is the type of stuff that people who need to go answer their questions are like, what the heck does this mean? But in reality, wouldn't you want to provide a view to end users that it makes sense to them? I'm showing them the same words that they think about, right? And if they're curious, what does an order mean, for example, they can get the definition and they can go understand who's the person behind that in case they have more questions, and where is the data connected to that. And essentially what you start doing is, I want to go compare what is this application-centric versus knowledge data-centric view of the world. So if I have this very simple question, what are the orders and their net sales in a given time period per their status? If I'm going to go run that question over that application-centric database, this is a typical really complicated SQL query that you have to go do, right? And not many people are able to go write this type of SQL query. And this would get copied and pasted all over the place and get sent to other people. But when you think about it from this knowledge and data point of view, your model is very simple. An order has a net sales. It has a time that was placed. It has has an order status, and the order status has different types. And now your queries, which in this case, yeah, it happens to be in a graph query language, which is called Sparkle, but these queries are much more manageable, and they're in terms of that knowledge layer. And all of this is connected. So what happens if tomorrow we did the a definition changed, like the net sales changed for some reason? Well, on the left-hand case, you have to go keep track of everywhere where all that query was copied and pasted and go figure out what changes need to be made. In the right-hand side, in that knowledge part, you just change the definition of what is the net sales in one place. And then everything else continues to be the same. It just so this and essentially becomes a much manageable way to go deal with all the data. Remember, it's just a higher level of abstraction. So we talked about open data and enterprise data, and one of the topics for today was on governments and how we're going to be evolved to this. And I believe that the way the open data catalogs and these enterprise data catalogs are all both heading in the same direction. They're open data catalogs, right? They're providing data so people can go answer questions for transparency reasons. Enterprise data catalogs within the companies are doing it for the same reason too. And if these things start to merge together, this is when we start seeing this whole data marketplace, this whole notion of a data marketplace. And I'm really fascinated about the opportunities that are gonna occur here. So let's say I got some internal data, and I'm an insurance company, for example, that we're trying to go analyze different types of claims. And I have to go deal with this particular data, and I'm doing a claims analysis over my data. And I'm doing, for example, I'm looking at fire-related claims, and I'm looking at the loss ratio. And I do my analysis on my own, but I realize, wait, that doesn't really tell me much about this. But on the open data, for example, FEMA has all the information about fire stations. So I can go get that data from the fire stations, literally just download it from FEMA. I can also and I can also find some other data sets that can connect zip codes with Latin longs, because maybe my internal data has the Latin longs information about things, and the FEMA data only has zip codes. So I want to go connect things through Latin longs. The moment I start connecting all these things together, this is a particular analysis that I can do just by bringing in that external open data. And I realize, wow, I got a bunch of claims on locations that have a low loss ratio, that have a fire station nearby, and I have a lot who are higher loss ratio that have a fire station further away. I think third-party vendor data is going to come into place. So you can say, for example, that we have vendors who will have detailed information about other data, right? Housing data in Austin, for example. Okay, get information about houses and what year they were built. Do they have a fireplace or not? And if I start pulling all this data together, I realize, oh, wow, the orange means that the houses they have a fireplace. And you can see there's a big orange kind of in the bottom right. That means that the higher loss ratio and older houses are having fireplaces. You can start making all these different types of analysis when you start bringing all this data together. So I think we have all our internal data within organizations. Open data is being released, and there's this huge opportunity to be able to combine and provide a marketplace to combine all this data. And then you can imagine having a combination of internal data with external open and third-party data all together. I think another opportunity we're seeing is to have all these reusable industry-specific data models, right? So at the end of the day, right, this is an example of what an insurance world will look like. It talks about policies and claims, and this is a very simple view of it. And this is how the business users think about it, not necessarily, and it's regardless of the complexity of your different data sources. So I'm going to pass it on to Brian.
Yeah, so I'm gonna go real quickly here through another real world example. So we'll just talk through kind of a number of the different examples of the kinds of research that this way of thinking about data can give you. I want to talk through a real world example here. So this is some work done by Dr. Steve Kramer, who I actually know is on the call today. So hi, Steve. And he did this in conjunction with data.world, and he and our CEO Brett presented this work. I think it was a couple months ago. But basically, Steve's work has been around detecting automated accounts claiming the coronavirus is fake or a hoax, accounts linking to Russian websites. I'm going to focus here for these couple slides on one slice of this research: pro and anti Dr. Tedros accounts. He was the head of the World Health Organization. Step forward. So this is the kind of, the final conclusion. Out of an initial set of about 4,500 automated COVID accounts, there were a bunch of automated accounts, some pro Dr. Tedros and supporting him, some critical of him and trying to discredit his work. Step forward. So this is some of the network analysis that went into this work, basically identifying all of these, identifying Twitter streams and characterizing the various accounts as being automated bots, detecting the disposition of those bots toward the topic, seeing them in relation to all of the standard accounts and the tweets and websites that they talk about. And you can see here, I picked this picture in particular out of Steve's presentation because you can see here, this really kind of visually shows that all of, when you look at the data this way, all of the anti accounts are clustered together in a very visually compelling way. So this is, this is kind of showing the types of analysis being used by the researchers producing the work. Next slide. But also, we've also then captured here kind of the high level analysis, a high level aggregated analysis showing these competing botnets over time. So this is basically taking that very detailed work that was used to identify these accounts, but then turning this into a more consumable infographic that shows more lay folks what was actually going on, how these two bot networks were actually in competition with one another. And stepping forward, the end result here is a system where you can pull together data from a number of different sources. You can analyze it both for experts who are applying very sophisticated analytical techniques, but also produce results that are consumable by folks who just want to get to the final answers. And you can publish that result. This exact research is available through that URL from the Kung Fu AI team on their data.world account. You can go see the results of this analysis. You can go dig into it yourself, reproduce the work, see if you want to be able to take that work and carry it further in your own research.
So I think we're right on time to kind of wrap up, and I do want to leave people with action items. You guys all have homework here. I have my call to arms. Define what success looks like when it comes to data. I am tired of hearing all the time, we need to go integrate these 10 different databases. Why? Why didn't you go do that? Okay. I always tell people, imagine magic wand, it's integrated. So what? Define what success is. And most importantly, who is it for? Because if we don't, because the data is for somebody. Remember, integrating data is not the end goal. It's a means to the end. So we really need to understand what the end goal is. Now, here's something that I've learned talking to people within organizations is that they realize that they're sometimes, because they're asking these questions, they're probably in the wrong part of their organization, or they realize I need to be talking to a different side of the organization, because whoever I'm working with, they don't even know what success is supposed to be. Get your data in order. Honestly, people right now, a lot of organizations have people who are going to be retiring in the next 5-10 years. I know so many cases where people are just throwing money out to the people who are about to leave the door because they're retiring, because they still don't know what's going to happen. I mean, the notion of please don't let Bob retire or Alice retire, that's a real thing right now. Now, second is get your data in order, because the next generation workforce, the millennials, are going out. If your organization and you deal with your data in spreadsheets and you have to go email people to go get data, or are you an organization where you have your data organized, where you have a really cool data catalog that has really great user interfaces and search capability, where do you think people are going to go work? I mean, honestly, the way you run data within your organization is a reflection of how you run your own organization. People are going to want to go work at the place where they have the data in order. This notion of a data product management, there's this new role. It's starting to become more and more visible. Ask yourself, who is responsible for your data? Who does this knowledge work? And are we actually training the next generation of data workers correctly? A big call for arms for the academics, for the educators in the room. We need to really think about how to educate folks like this. And I think we're going to start shifting from, hey, don't share my data, to no, share my data unless something happens.
Yes.
Right? It starts internally, and we don't want to go reinvent the wheel. And again, understand your users. So just kind of a final wrap up. We've been talking about knowledge graphs. There's a article coming out in the Communications and ECM in next month, article that I wrote about the history. I have a book coming out very soon about how to go build these things. We have other papers here you can go find if you want to get into the details of that. We have an honest, no BS, non-salesy conversation about data every Wednesday live on Catalog on Cocktails. That's our podcast. So I started this and reminding you guys, it's time to transform data management. Technology is not enough. We need the people, data product managers, knowledge scientists. We need to be agile. We need to define success in terms of the end users. And the technology's there. The technology's there, but it's not just technology. And with that, Jay, Jessica, thank you very much for inviting us.
Thank you guys. Great. That was a lot of information. That was wonderful. We've already had several requests for the video and slides. For everybody, we always post the slides and video later. Give us till tomorrow. Actually, Jessica, maybe posted on YouTube right after this, right?
It's live on YouTube right now. Say hello on YouTube. Yep. So everything will be, we have a YouTube channel, everybody. This is very exciting.
Yes, we finally joined the 2000s and started a YouTube channel.
We're at the top of this.
So Juan, if you could, release the screen, or Brian, so I can share a little bit. Hold on one second. We have just a couple more slides for folks before we start the Q&A. Let me see if this is presenting. Is this in presentation mode? You all seeing that? Great.
Yeah.
So stay with us for Q&A with Brian and Juan, and it's a chance to win a South by 2021 badge. Jessica is going to pick questions. Her favorite question, she's going to hold till about 7:55. If you're online, she'll promote you. You have to submit the question with your name, right? We don't want any confusion about you taking credit for someone else's question if they're not here anymore. So the question must be under your name. We'll have to collect that information from you. Real quickly, we have some great events coming up. In just 2 weeks, we're going to do how technology is making food faster, better, and safer, and for more people. We are still putting together the final touches on that event, but trust me, that is going to be a wonderful event. You're going to feel good about what some technologists are doing in the areas of food production, food distribution, food safety, and more. New event on COVID-19 variants, vaccines, and the future of pandemic tech. So we're going to talk about what went into the RNA-based technologies for rapid development of vaccines, how we rapidly sequence the different variants that are out there and understand what might work against them, and how this pandemic is changing the nature of technology related to detecting illnesses, testing for them, predicting their spread, and developing drugs and vaccines. April is going to be AI month. We're going to have a lot of stuff that month, not one event, not two events, possibly not just 3 events. We may do an event of some type every week in April. There's a huge topic in Austin. So many wonderful AI companies and so many national and global companies with strong AI presence in Austin. May is going to be all about smart cities. So that will reference some of what you hear the previous month and how we can make our cities effective, safer, healthier, more mobile, cleaner, more resilient, and so on, using edge computing, analytics, AI, and more. June is going to be a month about blockchain and about Bitcoin and cryptocurrencies. We'll probably do 2 events that month, one generally on blockchain and one specifically on Bitcoin and cryptocurrencies. And of course, later in the year and earlier in the podcast and such, we'll do gene editing, neurotech, money and finance. I think I saw one of my CVEX colleagues on this call. We got to get that set up and much, much more. We also have some new event types. The pandemic has been terrible, but some silver linings are us reaching more people and having new event types. We already did one of our tech and whiskey chats. We did AI whiskey in 2021. I hosted that with Matt Sanchez of Cognitive Scale. We will continue to do some of those. I love the ideas I saw in chat earlier about different themed events. We'll do some small group discussions, some tech and movie nights with Q&A with experts after the movie. Was that realistic? Was it not realistic? We'll do some tech book discussions and more.
Please join our Austin Forum Slack. Super simple. Go to the website, click on the Slack page, click join the Slack channel, enter your email address, check your email to confirm the Slack invitation, enter your name, and click create account. And you're in, and you're a part of our community.
Again, thank you to all of our annual sponsors. I'm not going to name them all right now since we're running a little bit over, but you see global national technology giants on here. You also see really strong, passionate Austin companies on here. They make all this possible. Thank you again to all of our partners.
And I see our friend Catherine Craigo. We know that one thing that the pandemic has underlined is the digital divide. So we are really committed to helping others, help others get connected during COVID. So we encourage people, donate your devices to Austin Pathways. There are people in Austin right now who need this device to be able to learn, work, and be well remotely. Austin Pathways is a fantastic program. They will safely pick it up from you, refurbish it, and deliver it to residents. Thank you, Miss Kate Craigo, to everyone. We are super thrilled to be to partner with them. You can give them a call or an email, and they will set it up. And we will include this on our follow-up email too. Thanks.
And I have a Dell XPS 15 that's right up there that I'm donating to this. So I know many of you have older laptops, tablets, and phones. Please consider donating them. If they're sitting in your drawer, they could be on someone else's desk. So please use those. Also help us spread the word via social media. We really appreciate that.
Oh, one of my questions. So in the chat feature, the closing question before we take a little whiskey break and then come back for Q&A. What was the most fun thing you learned or heard? What was the most interesting thing you learned or heard tonight during this presentation? We love to hear what was meaningful, what was interesting. We'll change the question to what was most interesting. What was the most fun or interesting thing you learned or heard? Put it in the chat. This is one of my favorite parts. It's about the people. People drive data transformation. Absolutely, Kate, we agree. Love it. Picture is worth 1,000 words. I know people were chatty though, and a lot of people were already listening, asking for the recording, saying how great this was. So I know that there must have been a lot of good things. Questions? That there needs to be a person in the middle to describe the data. Absolutely. Awesome. We'll keep sharing because we love to see that.
Manager before. That was new to me, Juan and Brian. All right. We're going to take a not 3 minute, we're a little bit over, so 2 minute break. And we'll reduce the Q&A session just a little bit because we're still going to end at 8. But if you can stay for questions, you get a chance to win a self-buy badge. So
you must stay on.
Take a quick break and we'll start in 2 minutes.
I am actually going to go get a whiskey.
Go get it. Jay would prefer not to drink the whiskey alone, literally or figuratively.
You will.
Thank you, AZ. Thanks everybody for being here, and all the new people, welcome. If you're new, let me know how it goes. You're going to get an email follow-up from me after this event too, so feel free to email me back. You probably receive multiple emails from me if you're here because I always send multiple emails leading into it. Jay, what are you drinking tonight?
I'm drinking Russell's Reserve Kentucky Straight Bourbon 10-year.
Wonderful. And Coke?
No. Who said that?
Exceeded. Thank you, Dr. Steve Kramer. It was great to see you. .org. If you go, oops. Do I get to bring questions up?
Yep, you can bring them up live. We're just going to ask everybody, ask your questions very quickly. And Brian and Juan, just so we can get through more questions, short answers, please. And then we can start a data channel in the Slack workspace and take some more questions there.
Ask your question that you wrote in the Q&A. Last time I promoted somebody and they asked a question, but I was like, that is not the question I invited you for.
Julie, I totally appreciate that. I'm glad we've converted you from vodka to real stuff. That's good. Like
Julie,
that.
It was one of the highlights for the Whiskey and AI chat for me was like seeing you seeing your face on the Zoom and not just being CVEX. So that was really fun.
All right, let's go.
Okay, start now. Hold on. Sorry, people are chatting me and okay, well, I'm gonna actually. Brian was super helpful and we are going to go backwards. So we are going to bring up Miss Kate Craig-O'Blanton. Miss Kate, hey, do you want to share you put a combination? I know you put, did you put questions on or maybe, sorry, I might have promoted the wrong person.
I do have a question.
Okay, really quick. So sorry. I was like, I thought I saw your name, and then I might be thinking Kathy and Kate at the same time.
So I work in public housing, and technology is unevenly distributed. And thanks, for folks' donations to Hawker residents. What about the question of the equity of data sets? How do we make up for the fact that we just simply don't have some people's data when we think about governance and learning from data? For maybe social good or public good, even access to data. Also maybe around ontologies and language, the idea that people use different terms for different things. So maybe, can you speak a little bit about that?
Sure. Actually, I think I'll tackle the equity question, and maybe Juan, I think you have some thoughts on the language and ontology segment. I mean, I think there's no silver bullet to magically collect data from folks who are underserved. I think a lot of how I look at it is that by increasing the utility of data that is out there, by increasing awareness of open data sets that exist, and by getting them into use and demonstrating that they can be used to learn new knowledge, to achieve societal outcomes, creates more of an impetus to collect and create better distributed, better machine readable, better standardized data sets. And I think that's the lever we try to pull on increasing equity in data, is making sure that we're increasing the equitable use and access to data. We're making sure we're increasing the usability of the data that's out there, which will create that flywheel effect of better collection techniques and better stewardship of those curated data sets at the source.
And on the schema models part, I just shared something in the chat. I think we need to get into understand how we can collaborate from different kind of folks from different communities. And it's not just kind of this tied industry consortium. And I shared schema.org. Schema.org is something that started by Google, Microsoft, Yahoo, Yandex to go create a vocabulary to describe things for search on the web. And it's completely open now. Like anybody can joins and they start extending it. So that's an example that it is possible.
Fantastic. I'm going to pick a variety of questions. It was actually very helpful, Brian, when you started sharing the ones that you're really interested I know that this next one is, let me see if I can find him. Great. I'm going to bring up Dave because I know he has a question about buying and selling data that a lot of people have. So, Dave, you're up if you'd like to share your question and you can hear us.
Dave, you're on mute right now.
Yep, you're on mute. He might not want to share his name.
He just asked us to read it. He said,
yeah.
He asked us to read it. His question was, do the panelists think users should have to do something to prevent their data from being sold, or should no selling of user data be the default? And this is a complex question. I think there is a simple element to the answer, which is that my personal take is that you should own your own data about yourself. The question is, what really you mean by default, and what how you express both the license to use data for certain purposes, which is often used to provide you back services and analysis and information, and how it can be used for exigent. I think really the nature of your question is unintended uses by you. And yeah, you're bringing up Solid. I mean, Solid. Juan mentioned Tim Berners-Lee earlier, and if y'all aren't familiar with him, he's the inventor of the web, but also the inventor of a lot of the concepts around the semantic web, RDF, OWL, the semantic things that underpin a lot of the knowledge graph tech we talked about tonight. And that's one of his more recent projects, which is really, that's really what I mean in terms of ownership. Ownership. I think the simple answer to your question is that you should own the data about yourself, and that it needs to be kind of an inversion, and legally it needs to be an inversion control of what do you license to be done with it. And Dave put a link out there to Solid project. If you're interested in this topic, definitely check that out, because it's a mechanism to basically turn that policy thinking into technology and actually put you in driver's seat from the source of your data, so that you own it and you actually control technologically the access to your own data. And I think something like Solid is a fantastic idea, and it's just, sorry, Juan, and then the problem is moving from where we are right now to that is a really hard problem, and I'm supportive of it. It's a giant lift. Go ahead, Juan. Sorry.
No, Interrupt is a company that Tim Berners-Lee started to go try to commercialize this, and they're doing a lot of stuff like in healthcare and stuff to go do that, because you want to own your own personal health data, but you still want to go move it around. So that definitely look into the Solid project.
Fantastic. And I'm going to promote Ari. I'm just going to assume people want to be promoted unless you tell me in the chat as I'm doing this, because his question seems to tie onto something that you were just bringing up also. So let's bring Ari up, who will be rejoining. Oh, there he comes. Ari, can you hear us? Are you there? Ari, you're on mute if you can hear us. Otherwise, we can just read his.
No,
okay. Yep. Go. Take it away, Juan.
So you guys, what's the status of RDF and OWL in the current semantic web technologies? Have these 2-decade-old technologies been superseded? And then I didn't present them in the slides. Honestly, they are strong, and they are the future right now, and they're the basis of all these different technologies, all these different companies that we're talking about, even data.world. I on purpose don't bring up RDF and OWL. It did it on the talk because you'll hear Neo4j and all these things. At the end of the day, it's all a graph. It's all bubbles and lines together. But RDF is a standard for it, and that's what is the basis of all the technology that we're talking about. So it is going strong and even stronger.
Great. I'm going to ask the next question, because she already said that she got off, and it looks like a good question from Angela. So open data is about transparency, participation, and collaboration. These qualifiers are in the initiating Obama EO for open data. The idea of open data is to promote participation and collaboration for the public good. Subsequent legislation relates to providing data so that better policy decisions may be made, so that we can create an evidence-based policy-driven democracy, blockchain leading data control. So the question, public data doesn't need access controls because it's public. How are you building the democratic goals and democratization of data here? This presentation seems far more directed towards helping organizations figure out their data than advancing a society technology goal.
Yeah, so I raised my hand to answer this. It's a great question. So I think, one observation I'll make, just kind of like zeroing on the last sentence, that, she said the presentation seems far more directed towards helping organizations figure out their data than advancing a societal technology goal. I think those are one and the same. Like the organizations that manage the public data that can be used for good, by and large, don't do a fantastic job at it. And so helping those organizations make sense of the data that they are the stewards of and get it out there and more usable is actually one of the best ways that we can help increase transparency, participation, collaboration. There's a lot of the legislation that she's talked about. There has been some great legislation in the U.S. and there's similar legislation in a lot of the world around promoting the notion that government agencies are required to publish data openly, but also to do so in machine readable formats and with standards, including DCAT, one of the standards I talked about earlier, which is actually, so if you look at the US federal government, people are probably familiar with data.gov. Data.gov is kind of the implementation of a set of legislation that requires every federal agency to publish certain pieces of their data publicly in a machine readable format so that anyone can fetch them and understand them. And Data.gov was really the implementation of a technology system to aggregate all that and bring it into one place. We actually, at Data.world, we've actually participated in the Data Coalition, which is an organization, effectively a lobbying organization for promoting this kind of legislation. And when I talked about the open catalog, the catalog of hundreds of thousands of open data sets, a large amount of that is syndicating these open data catalogs that government agencies, NGOs, other nonprofits, universities, journalism outlets publish to make sure that that data is maximally usable. We take that data and we syndicate it through our platform, which gets you beyond that metadata layer to actually being able to go in and query the data, interact with it, join between multiple data sets, and eventually start layering knowledge on top of it.
There's two questions here that are kind of related. I'll answer quickly, if you mind. I think Don Stevens, you talk about 2 potential or 3 data persons. What about the non-techie leader persona? And then Roland asked, could the product manager role be transitioned into the knowledge scientist role? So those two, I think I'll take them together. Answer is yes. And I think by transitioning the product manager role into a knowledge scientist role, that's how you get the non-techie person in there. And I think we need more that mindset of a product manager to think about data. So we definitely need to go learn all those techniques that data scientists don't know, right? So that's the way that we need to have that. And I think that data product manager doesn't need to be the person who's like with their hands roll up their sleeves with the data. They're the ones who are more on the non-techie side, who's like, I'm going to be managing. I know how to go manage a group and stuff. And I think the data product manager is going to manage a team of knowledge scientists. So that's how I see that going forward. That's my prediction here.
The only caveat I would make to that one is product managers are supposed to know that everything from soup to a little bit of everything from soup to nuts on the technology, the engineering, the business case, et cetera. So I'm not sure I would think of them as being someone that's not scientific or technical.
But they're not the person who's going to sit down and go debug a 15-page SQL query.
Right.
Well, knowledge scientists is look into
that's
that.
you.
There is knowledge in that query that I want to go extract, and I'm going to hypothesize what this means, and I'm going to do it. And I actually use the word scientist on purpose because there is unknowns that need to be turned into knowns, and you have to go through the scientific process for that.
Yeah.
I got 2 more that I think we'll be able to do in this time, maybe 3. But I'm going to bring up Brittany Lyons, who had a few good questions in the chat too. Miss Brittany, you are up.
Hi. All of my questions disappeared from the chat.
Okay.
Yeah, so I think you touched on these concepts a little bit already, but what are you doing with data.world to help ensure data privacy and security, specifically around like individual data? Can different companies share data with each other and potentially build these like super profiles that could then be used for decision making? That's my question.
That's what I found.
Yeah. So great question. I mean, I think it's interesting because we kind of operate at two layers when I answer these questions. And I want to make sure people understand the clear delineation because it's an important one. One is because we actually operate this large open network of individuals, we are first party data collectors of that, right? We have over 1 million open users plus all the users and all of our corporate customers. And so we actually take in personally identifiable information about those people because they have accounts with us. We don't make that data available to anyone for any reason other than the purpose of just simply using it to operate data.world. But then when you get down into the within the data that we're within our organizations who use data.world, how do we manage, so you asked privacy and security, two very different things. I'm going to focus on security for a second. Security, absolute paramount. We are basically, our corporate customers are basically using us to manage metadata and access to real data. And so that's completely siloed and firewalled off. And part of the answer then to your privacy and what can people do with that data and is we give them the guardrails to manage their data well, to understand what they're doing, to implement governance practices and privacy practices. And within that realm, I don't look in and try to govern what our customers are doing with their data inside of that organization, because that's very strictly not my place to do. I'm providing a technology platform for them to implement governance and policies and all of those things, all of those things within those four walls. But I not only don't look in there, I can't look in there by design in the system. And then could those organizations share between one another? Yes, they can. One of the benefits of using a kind of cloud-based, web-based platform like this is that organizations can say, yes, I'd like to share these data sets with this other organization. And does that present the opportunity for folks to share things? You're indicating that certainly people could share things that you would rather not be joined together. That reality exists today, right? If people would like to share data sets and build up virtual profiles by comparing personal information, it exists today. What we do is basically give folks the ability to say, you have a catalog of your data, you understand what your data is, you can implement governance and privacy policies on top of that, and then we support the notion of federated sharing of data between those organizations where that makes sense. Did I answer your question, Brittany?
Yes, thank you.
Awesome. Thank you so much, Brittany. Okay, we got one. Hold on. Last time I moved Jay into being an attendee, which he didn't appreciate. So I'm making sure I move the right people in and out. We have time for, I think, one last question. And so this last question is my favorite question, which came in just under the gun and luckily moved it to the Q&A from the chat for the night, which is Marben. Marben, are you there? See Marben, but can we hear Marben?
He doesn't have a microphone connected.
He doesn't have a microphone connected. Well, but clearly he can hear us. So what? We'll ask his question on behalf of him. So how do we incentivize data creators and owners? Oh, he lost sound. Well, I'll ask your question and then you can watch the recording later and see it. How do we incentivize data creators, owners to make their data available and beneficial for others beyond satisfying their own answers and goals, as doing so usually suggests more time and work after their return of value? I mean, I think this is a core question. If we're saying all of this, how do we incentivize the whole process?
Yeah.
And before you answer that, it is a great question. And Jessica probably doesn't know this because she's newer to the Austin Forum, but Marben has been coming to forums for years. And every year he seems to ask a winning South by Southwest badge.
Oh, I had no idea.
And I know, and he did it again. Marben, that is a great question. Go ahead, Brian.
Yeah, no, it is a great question. I mean, and there's a number of things we could say around, helping folks understand how to monetize their data, make sense of it. But I was thinking about this question when he first posted it. So I'm going to post a link in here. I would recommend, a lot of the way I think about this was guided by somebody named Mallory Soldner. Mallory Soldner worked for UPS, the delivery system. And I just posted a link to the TED Talk that she gave. So for a deeper answer, go watch that TED Talk. I think it's really kind of insightful and inspiring as to how a company can both do good and also do well by sharing their data. What they did was shared a lot of their logistics data from their delivery network to help folks trying to build better systems for improving the efficiency of logistics systems to get medication and aid to folks to folks in need. And what they realized was, hey, free for nothing, this data that we shared helped actually save a lot of lives, but also having a lot of people look at our data taught us things about insights that could be gleaned from the data that we would never have been able to do completely on our own. And it goes back to one of my favorite quotes that most of the smartest people in the world don't work for you. By getting your data out there in the world, not only can you maybe do some good with it, but you're also way more likely to learn things that your data can teach you that you could never learn by keeping it locked up.